Hello, in this project for the class of Mechanics of Structures 2, we are going to analyze the Twin Towers beam theory and columns.
The North Twin Tower has the characteristic of having a constructive system formed by a central structural core formed by 48 concrete covered steel pillars and bearing facades with steel columns, which were connected to the trunk form a network of steel beams.
We calculate that there were 48 columns in the nucleus and 76 exterior columns.
Each tower contained amount 110 plants, around 100,000 tons of steel.
To calculate the total moment of inertia xx using the parallel axis theorem for one floor. As we know, in the center of the tower, we have 48 columns as a core of 1.4 by 1.4, and around of the tower 76 columns of 1.2 by 1.2. First, we placed inside and outside columns in an Excel document to calculate the parallel axis of IXX. In the architectural plans, we calculate the distances between centroids from the red axis. From each column, we calculate the area and distance from the centroid to each column. To use the formula IXX equals sum of IX1 plus A1 D1 squared. And the result was this.
Calculate the Euler's critical load for one floor using all columns. Allowing a column calculate three effects: stable equilibrium, neutral equilibrium, unstable equilibrium. If the load is less than the critical load, the column is in stable equilibrium. If the load is the same than the critical load, the column is in neutral equilibrium. If P is greater than the critical load, the column is unstable equilibrium. The critical load formula is this. The modulus of elasticity is 200, and the moment of inertia is 73,139.3454, and the effective length is 3. We multiply the height of the column 33 by 1, that is equal to K, to be an articulate column. This to square results that the critical load is 1.60 times 10 to the 16.
Calculate the damage moment of inertia for the most critical floor, where most columns disappear, using again the parallel axis theorem and less column than in step 2. With the calculation tables of the moment of inertia in exercise 2, based on an investigation and assumption about the attack on September 11, one of the most damaged floors of the North Tower was 96th floor, as an intermediate of the floors 92 and 99, that were also damaged, and removing columns 1, 2, 3, 4, 5, 8, 9, 10, 11, 15, and 16 of the core, and columns 5 to 17 from the outside as shown in the image. From the elimination of these columns, we'll calculate the moment of inertia as we did previously, resulting in 53,052, period 98.
Investigate the reduce in for a heated steel. The modulus of elasticity low when the temperature rises, therefore must be less than 200, which is 150 as an estimate.
6. Calculate the Euler's critical load for the damaged floor. In this part, we replace the inertia of a normal floor that we had calculated by that of the damaged floor, resulting in 8.73 times 10 to the 15.
Estimate the amount of load above the critical floor and compare the load of step 6. For this point, we use the 96th floor as a critical floor, taking into account that there are 14 floors above. Then we analyze dead loads such as installations, roof, ventilation, air conditioning, floor, concrete slab, sheet metal, steel, wall divisions, exterior walls, and overloads. We also analyze live loads, such as office and the roof, resulting in a total this.
In conclusion, for the analysis and the assumption of the number of columns that collapse and comparing the data of the damaged floor together with their loads with another floor that was not damaged, despite the damage of the columns, the structure had to endure the impact. However, the modulus of elasticity goes down as the temperature of the steel increases.
Due to fire causing the modulus of elasticity to fall below 150 in less than 6 hours, transmitting the heat to the lower columns, thus causing it to collapse.